everyone. We're working now on antiderivatives. This is section 3.9. So what I was going to do was just pull out a few problems to show you the technique. I'm going to start with an easy one, number 3, and get harder. So number 3 is f of x equals 2x cubed minus 2/3 x squared plus 5x. And what our instructions are, find the general antiderivative of your function. So find the antiderivative, the general antiderivative, and check your answer. Okay, so the antiderivative for f, I'm just going to call it this. I'm just going to say that. So what we're going to get is, all right, we have to use the inverse power rule. So we add 1 to the exponent and divide by that power. So 2x to the 4th over 4. And we'll check this. So we're doing, remember in the power rule, we decrease the exponent, we bring the exponent down, decrease it by 1. Now what we're going to do is increase it by 1 and divide it. Okay, so then here we're going to have 2/3 x cubed over 3 plus 5x squared over 2 plus a constant. And we don't know what that is. It's just a number. Okay, let's clean it up a little bit. Well, 2 can go into 4, so x to the 4th over 2 minus 2/9 x cubed, 3 times 3 is 9, plus 5/2 x squared plus c. Okay, let's see. If I take the derivative of that, will I get that? If I take the derivative, so if I go ahead and take the derivative of this thing, I'm going to look at it like this, we would have 4 times x cubed over 2. Okay, that simplifies to 2x cubed minus 2/9 times 3 times x squared. And the 3's would cancel and we'd get minus 2x squared. Minus, oh sorry, I put a 2/3 instead of a 2/9. Okay, so we'd have 3 times 2/9 times x squared. Now this would simplify to 2/3 x squared plus, if we bring the 2 down, and then we'd have 5/2 x to the 1, which when we simplify, that didn't look like anything. When we simplify, it would be 5x, and then the derivative of a constant is just 0. So we've confirmed that if we take the derivative of that, we get the original function. So this is the antiderivative of the original function. Okay, the general antiderivative. Okay, so let's do another one. Let's make it a little bit harder. Let's do number 15. Now number 15, I'm given g of t equals 1 plus t squared all over the square root of t. Okay, well, at this point we're not going to try to invert the quotient rule. So don't look for that right now. What we need to do is rewrite this in a form that we can go ahead and take the antiderivative of. And the way we do that write the bottom. We got to write all our exponents in terms of no square roots, no cubed roots. We need to, so a square root is t to the 1/2. Cube root would be t to the 1/3. Fourth root would be t to the 1/4. We need to write it in this form. Now there's two ways you can think about this. Let's think about it this way. I'm also going to bring this up and write this as t to the negative 1/2 times all this stuff. Now I can distribute. We're not gonna invert the product rule either. So I'm going to distribute. T to the negative 1/2 times 1 would just be t to the negative 1/2. Plus t to the 1 times t to the negative 1/2 would be 1 t to the 1 plus negative 1/2. T to the negative 1/2 times t squared would be t to the 2 minus 1/2. 2 plus negative 1/2. Okay, so now we would have t to the negative 1/2 plus t to the 1/2 plus t to the 3/2, right? Okay, 1/2. Okay. So we got to do lots of fraction arithmetic. So now, to get the antiderivative, we're going to do this. Remember, to get the antiderivative, you add 1 to the power and then divide by that number. So I'm going to add 1 to this. Negative 1/2 plus 1 would be 1/2, and then divide by 1/2. I add 1 and divide. Here I add 1 and divide. Here I add 1 and divide. And then I have to add a constant. Okay, that looks nasty. We've got to fix that. We've got to simplify that a bit. So what you have to remember in these problems is when I divide by 1/2, that's equivalent to flipping the 1/2 and multiplying. So I flip and multiply, I get 2t to the 1/2. Flip and multiply, I get 2/3 t to the 3/2. Flip and multiply, I get 2/5 t to the 5/2, and then I still have the plus c. So that's our answer. And what you need to do to check it is to actually take the derivative. So when we take the derivative, for instance, in the first term, we'd have 1/2 times 2, which is 1, and then we decrease the exponent by 1, so we would get t to the negative 1/2 in that first term, which is what we would expect to get back the original g. Okay, I'm going to let you do the rest to practice. Okay, so let's do another one. Let's add, we're going to do 3 more and add a wrinkle each time. Something a little different each time. So how about we do 25? In 25, we're given the second derivative. Okay, we're given the second derivative. And we want to get the original function. So we're going to have to do the antiderivative stuff twice. Okay, so this is the second derivative. To get the first derivative, okay, we need the antiderivative of 4, that would be 4x. And we need the antiderivative of that. So what we need to do is add 1 to the exponent. So 3/3 plus 1/3 would be 4/3. And divide by 4/3. And then we have some constant. We don't know what it is. Okay, so now we've got to take the antiderivative again. So we're going backwards. We're going from the second to the first to the original function. So the antiderivative of this, remember, you add 1 to the exponent and divide. So it would be 4x squared over 2. Add 1 to the exponent and divide. Well, 3/3 plus 4/3 would be 7/3. And then on the bottom we'd have 4/3 times 7/3. Plus c times x. C is just a number. Plus d. Okay, we can simplify this a little bit. 2 goes into 4 twice. Now, this would be 4 times 7 is 28. 3 times 3 is 9. So it would be 28 over 9. Invert that. So there's our original function. Notice if you take the derivative of this, you're going to get this. If you take the derivative of that, you're going to get that. Okay. Let's do now 2 problems that have one little wrinkle in it. The little wrinkle is they're going to give us information so that we can get C and D. Okay, so first let's do 32. In 32 we're given the derivative. F prime of t is t plus 1 over t cubed. But notice and t is greater than 0. Okay. And we're also given that f of 1 has to be 6. So we're given one extra bit of information. So we take the antiderivative. So the antiderivative of t is t squared over 2. That's t to the 1. You add 1 to the 1 and divide. And then this is, let's hold on. Before I do this, let me write this as t to the negative 3. 1 over t cubed, t to the negative 3. So now let me go back. So the first one is t squared over 2. Okay, gotta be careful. We're going to add 1 to the negative 3. That would give us a negative 2, not a negative 4. We add 1 to the negative 3. It moves it to the right on the number line, so we get a negative 2. And then divide by negative 2. And then we have some constant c. Okay. So, but now, using this information, we can get that constant. I'm going to put in a 1 for t. When I put in a 1 for t, I'm supposed to get 6. So I put in a 1 for t here, I get 1/2. I put in a 1 for t here, I get negative 1/2. 1/2 plus negative 1/2 is 0, so c is 6. So now I know that my final answer is that. That's the original function. Check it. 2 times t over 2 will give me t. Negative 2 times t to the negative 3 over negative 2 will give me t to the negative 3. The derivative of 6 is 0, so this is indeed the derivative of this. Okay, let's add one more wrinkle. Just one more. And that is, how about 36? Now we're given the second derivative. Second derivative is 8x cubed plus 5. And we're given 2 bits of information. F at 1 is 0, and f prime at 1 is 8. So we're going to do the process twice to get to the original function. So first time, 8x to the 4th over 4 plus 5x plus c. Okay. Add 1 to the 3, I get 4, divide by 4. Okay, so let's simplify this. 8 divided by 4 is 2, so this would be 2x to the 4th. Okay, let's check it. 4 times 2 is 8, x to the cube. That, if I take the derivative of this, I get that. Take the derivative of this, I get that. Now let's use the first bit of information. Let's go ahead and put in a 1 for x, and we're supposed to get out an 8. Okay, well then c has to be 1. So now we know what c is. Now we take the antiderivative again. Okay, 2x to the 5th over 5 plus 5x squared over 2 plus x plus, we'll call it c again. Doesn't matter, we could call it something different. Okay, so now we've got this information, that f at 1 is 0. So we should put in a 1 here, and we get 2/5 plus 5/2 plus 1 plus c. It turns out that these add up to 3.9. It's a nice terminating decimal, so we can write it as 3.9. So c must be equal to negative 3.9. Okay, so that was 3 problems, 3, 15, 25, 32, 36, I believe. Okay, if you have any questions or you want to have a conference, please shoot me an email, and I can set up a Zoom room and we can talk. So don't be afraid to do that. See you soon.